As part of tools and techniques, we have the expert judgment, data analysis, variance analysis, charts, forecasting, reserve analysis, and 2 complete performance indices. We will discuss some in a lot detail than the others. Examples of expert judgment during the control cost process include variance analysis, earned value analysis, forecasting, and financial analysis. The data analysis technique that can be used to control costs include earned value analysis, or simply EVA. EVA compares the performance measurement baseline to the actual schedule and cost performance. EVM integrates the scope baseline with the cost baseline and schedule baseline to form the performance measurement baseline. EVM develops and monitors 3 key dimensions for each work package and control account: planned value, earned value, and actual cost. We will be discussing each of them in detail. Planned value, or PV, is the authorized budget assigned to scheduled work. It is the authorized budget plan for the work to be accomplished for an activity or work breakdown structure component, not including management reserve. This budget is allocated by phase over the life of a project, but at a given point in time, planned value defines the physical work that should have been accomplished. The total of the PV is sometimes referred to as the Performance Measurement Baseline, or PMB. The total planned value for the project is also known as budget at completion. Earned value, or EV, is a measure of work performed expressed in terms of the budget authorized for that work. It is the budget associated with the authorized work that has been completed. The EV being measured needs to be related to the PMB, and the EV measured cannot be greater than the authorized PV budget for a component. The EV is often used to calculate the percent complete of a project. Progress measurement criteria should be established for each WBS component to measure work in progress. Project managers monitor EV both incrementally to determine current status and cumulatively to determine the long-term performance trends. Actual cost, or AC, is the realized cost incurred for the work performed on an activity during a specific time period. It is the total cost incurred in accomplishing the work that the EV measured. The AC needs to correspond in definition to what was budgeted in the PV and measured in the EV. For example, direct hours only, direct costs only, or all costs including indirect costs. The actual cost, or AC, will have no upper limit. Whatever is spent to achieve the EV will be measured. Variance analysis as used in the EVM is the explanation for cost, schedule, and variance at completion. Cost and schedule variances are the most frequently analyzed measurements. For projects not using formal earned value analysis, similar variance analysis can be performed by comparing planned cost against actual cost to identify variances between the cost baseline and the actual project performance. Further analysis can be performed to determine the cause and the degree of variance relative to the schedule baseline and any corrective or preventive actions needed. Cost performance measurements are used to assess the magnitude of variations to the original cost baseline. An important aspect of project cost control includes determining the cause and degree of variance relative to the cost baseline and deciding whether corrective or preventive action is required. The percentage range of acceptable variances will tend to decrease as more work is accomplished. Examples of variance analysis include schedule variance, cost variance, Schedule Performance Index, and Cost Performance Index and Trend Analysis. Let's discuss them in detail. Schedule variance, or SV, is a measure of schedule performance expressed as the difference between the earned value and the planned value. It is the amount by which the project is ahead or behind the planned delivery date at a given point in time. It is a measure of schedule performance on a project. It is equal to the earned value minus the planned value. The EVA schedule variance is a useful metric in that it can indicate when a project is falling behind or is ahead of its baseline schedule. The EVA schedule variance will ultimately equal 0 when the project is completed because all of the planned values will have been earned. Schedule variance is best used in conjunction with critical path method, scheduling, and risk management. SV is calculated as EV minus PV. Cost variance, or CV, is the amount of budget deficit or surplus at a given point in time expressed as the difference between earned value and the actual cost. It is a measure of cost performance on a project. It is equal to the earned value minus the actual cost. The cost variance at the end of the project will be the difference between the budget at completion and the actual amount spent. The CV is particularly critical because it indicates the relationship of physical performance to the cost spent. Negative CV is often difficult for the project to recover. It's represented as equation CV equals EV minus AC. The Schedule Performance Index, or SPI, is a measure of schedule efficiency expressed as the ratio of earned value to planned value. It measures how efficiently the project team is accomplishing the work. It is sometimes used in conjunction with the Cost Performance Index CPI to forecast the final project completion estimates. An SPI value less than 1.0 indicates less work was completed than was originally planned. An SPI greater than 1.0 indicates that more work was completed than was actually planned. Since the SPI measures all project work, the performance on the critical path also needs to be analyzed to determine whether the project will finish ahead or behind its planned finish date. The SPI is equal to the ratio of the EV to the PV and is represented by equation SPI equals EV divided by PV. The Cost Performance Index is a measure of the cost efficiency of budgeted resources expressed as a ratio of earned value to actual cost. It is considered the most critical EVA metric and measures the cost efficiency for the work completed. A CPI value of less than 1 indicates a cost overrun for work completed. A CPI value of greater than 1 indicates a cost underrun of performance to date. The CPI is equal to the ratio of the EV to the AC and is represented by equation CPI equals EV divided by AC. Trend analysis examines project performance over time to determine if performance is improving or deteriorating. Graphical analysis techniques are valuable for understanding performance to date and for comparison to future performance goals in the form of BSC or BAC versus estimate at completion or EAC and completion dates. In the earned value analysis, 3 parameters of planned value, earned value, and actual cost can be monitored and reported on both a period-by-period basis, typically weekly or monthly, and on a cumulative basis. As the project progresses, the project team may develop a forecast for the estimate at completion, or EAC, that may differ from the budget at completion based on the project performance. If it becomes obvious that the BAC is no longer viable, the project manager should consider the forecasted estimate at completion, or EAC. Forecasting the EAC involves making projections of conditions and events in the project's future based on current performance information and other knowledge available at the time of the forecast. Forecasts are generated, updated, and reissued based on work performance data that is provided as the project is executed. The work performance information covers the project's past performances and any information that could impact the project in the future. EACs are typically based on the actual costs incurred for work completed, plus an estimate to complete the remaining work. It is incumbent on the project team to predict what it may encounter to perform the ETC based on its experience to date. Earned value analysis works well in conjunction with manual forecast of the required EAC costs. The most common EAC forecasting approach is a manual bottom-up submission by the project manager and project team. The project manager's bottom-up EAC method builds upon the actual costs and experience incurred for the work completed and requires a new estimate to complete the remaining project work. It's calculated by using the equation EAC equals AC plus bottom-up estimate to complete. The project manager's manual EAC is quickly compared with a range of calculated EACs representing various risk scenarios. When calculating EAC values, the cumulative CPI and SPI values are typically used, while EVM data quickly provides many statistical EACs. Three most common methods are EAC forecast for ETC work performed at the budgeted rate, EAC forecast for ETC work performed at the present CPI, and EAC forecast for ETC work considering both SPI and CPI factors. Let's take a look at them. This EAC method accepts the actual project performance to date, whether favorable or unfavorable, as represented by the actual costs, and predicts that all future ETC work will be accomplished at the budgeted rate. When actual performance is unfavorable, the assumption that future performance will improve should be accepted only when supported by project risk analysis. This method assumes that what the project has experienced to date can be expected to continue in the future. The ETC work is assumed to be performed at the same cumulative cost performance index as that incurred by the project to date. In this forecast, the ETC work will be performed at an efficiency rate that considers both the cost and schedule performance indices. This method is most useful when the project schedule is a factor impacting the ETC effort. Variations of this method weight the CPI and SPI at different values, and this also depends on the project manager's judgment. During cost control, reserve analysis is used to monitor the status of contingency and management reserves for the project to determine if these reserves are still needed or if additional reserves need to be requested. As work on the project progresses, these reserves may be used as planned to cover the cost of risk responses or other contingencies. Conversely, when opportunities are captured and resulting in cost savings, funds may be added to the contingency amount or taken from the project as margin or profit. If the identified risks do not occur, the unused contingency reserves may be removed from the project budget to free up resources for other projects or operations. Additional risk analysis during the project may reveal a need to request that additional reserves be added to the project budget. The To Complete Performance Index, or TCPI, is a measure of cost performance that is required to be achieved with the remaining resources in order to meet a specified management goal, expressed as a ratio of the cost to finish the outstanding work to the remaining budget. TCPI is the calculated cost performance index that is achieved on the remaining work to meet a specified management goal, such as the BAC or the EAC. If it becomes obvious that the BAC is no longer viable, the project manager should consider the forecasted EC. Once approved, the EC may replace the BAC in the TCPI calculation. The TCPI is conceptually displayed in the figure in front of you. The equation for the TCPI is shown in the lower left as the work remaining, defined as the BAC minus EV divided by the funds remaining, which can be either the BAC minus the AC or EC minus the AC. If the cumulative CPI falls below the baseline as shown in the figure, all future work on the project will need to be performed immediately in the range of the TCPI BAC, as reflected in the top line of the figure, to stay within the authorized BAC. Whether this level of performance is achievable is a judgment call based on a number of considerations including risk, time remaining in the project, and technical performance. This level of performance is displayed as a TCPI EC line.